All right, boys and girls, today is 7.4, day 2, so we're talking about exponential growth and decay, except today we're really getting into the story problem. So I need you to write this down. There is an exponential growth model. So the formula A equals P times 1 plus R to the T, where A represents the final amount, P represents the initial amount, R represents the rate, write it as a percent, as a decimal, and T represents the time. So we are going to set up a couple examples for you as we are talking about a savings account. So if you go into Day and you put in $250 in a savings account, it is going to earn you a 4% interest compounded yearly. So that means you don't have to make any deposits or withdrawals, and you come back in 10 years. How much money are you going to have there? So we need to set up the equation first. So A is going to equal my money that I end up with, okay? So P is my initial amount. In this case, it's $250. And then I'm going to take that times 1 plus my rate, which is 0.04. And that to the T would be how many years we have, so it's to the power of 10. So I need to add some things together here. So this would be 1.04 to the 10th power. And remember, order of operations tells me I need to do 1.04 to the 10th power first. So that's actually going to give me 1.48, and then you can round off 0 too, so I'm just going to stop it right there. So I just take that times $250, which would mean that after 10 years, I'm going to end up with $370.06. Now, that's going to be if my $250 just sits there for 10 years. I'm going to earn some money off of it, and that's how savings accounts work. Okay, so we're going to try another one, and this is going to be the same type of idea, except this is a $500 deposit. So I'm going to use my same formula. So A equals, the P would be my 500. I'm going to take that times 1 plus my 2.5% would be 0.025. And then this, I have 3 different options. I'm going to go after 1 year, after 1 year, 5 years, and then 20 years. So what's going to change each time is my exponent. So that would be 500, equals 500 times 1 plus 0.025 to the 5th. And I'm going to make this one a little smaller, so 500 times 1.025. This would be to the 20th. Okay, so again, you can put those all into your calculator. So this would be 500 times 1.025 to the first power. So you're going to solve that 0.25 to the first power first. You're going to take it times 500, and you're going to end up with about $512.50. If you're working through the next one, you're going to take your 500 and you're going to take it times 1.025 to the 5th. You're going to remember, do this part first. Take it times 500, and we're going to end up with $565. And the 20th one is already done for us, so we just have to take the 1.025 to the 20th. We're going to do that part first, and then you need to take it times 500. And I get 819. So basically this is saying if you put in $500 in the bank at 2.5%, which is a very small percentage, after 1 year you now have $512.50. If you leave it there for 5 years, and this is not taking anything out, putting anything in, you now have $565. And then after 20 years, if you forget about it and you come back, you're up to $819. Okay, so that's all great. But what happens if I've got this bigger thing here? And so this is saying a business has a profit in the year 2000. The profit increased by 8% each year for the next 10 years. So what's going to happen is we need to write a function that models this over time. So we're going to say, well, my initial amount starts at 10,000, okay? I'm going to do 1 plus my percentage, which would be 0.08, and we're going to go over 10 years. Okay, and so then what they want us to do here is we're going to actually use this to predict the profit in 2009. Well, since 2009 is actually only 9 years, 1.08, we're going to use it to the 9th and get roughly 19,990. Okay, so now we have decay. Decay just means that it's decreasing. So you'll notice that the only thing that's different with the decay model is that minus sign. So I'm subtracting something instead each time. So it says the population of a city decreased from 95 to 2000 by 1.5% annually. In 1995, there were about 357,000 people living in the city. So if I'm going to write my equation, I need to go since the year of 1995. Okay, so that's really important. So if we're going from 1995 to 2003, I need to talk about how many years that is. So I've got my initial amount, and I do my minus sign, but remember, like, this is my 8 here, and then remember, this is a subtraction sign. And so I work that out. Find the population. We're going to solve this part first. So you're going to do 357,000, and then you're going to do 1 minus 0.15, and you're going to get 0.985, and that's going to be to the 8th power. So if I work that out, it's 0.886 and multiply it by 357,000. Now, since it's decreasing, this answer should go down. That's what we want to see happening because it is a decay model. All right, so moving on to buy a computer for $3,000, you know that it's going to depreciate because that's what happens with technology. But this is at a 20% rate each year. So I'm going to write out my formula. I'm going to do 3,000 times 1 minus 0.20. And that would be to the t. And I'm going to just put that since I've got 3 different equations here. So this would be 3,000 times 1 minus 0.2 is going to give me 0.8. And this would be to the first. That would be 3,000 times 0.8 to the third, and 3,000 times 0.8 to the fifth. Okay, now remember, you always need to do your exponent first, then you take it times 3,000. So if I do 0.8 times 3,000, I get 2,400, or 2,400. If I do 0.8 to the third, and I get 0.512 times 3,000, I get 1,536. And then if I do it for 5 years, I end up with less than $1,000, which makes sense because after 5 years of owning a computer that was originally $3,000, it's a lot less. TVs are the same way, and we work through things like that. Okay, so tomorrow in class, we're going to go through some more examples, and we're going to try to figure out how to work some of these problems out.